Oops, back up. There we go. Okay. Yeah, go ahead, James.
I just wanted to say real quick that it's certainly true that the Arduino like Uno is a pretty simple processor, but what's really cool about the Arduino ecosystem and like getting used to it, getting used to programming in it, is that you can then trade up to, you know, doing bare metal on a Pi Pico from the Arduino environment or an ESP32. Those are also supported by that same, you know, library basically. And they make it really easy, but you're learning C++, which is, you know, probably the number one language. Oh, God, I don't want to start a war. But you know, it's a great language to learn and to move forward with. So yeah, I 100% agree that it's a wonderful starting point. I also want to say one of the things that drives me nuts is people like poo-pooing a simpler way of breaking into something new. So like block programming and Blockly, which is available for a lot of microcontrollers, and MicroPython, if you like gag Python. I mean, lovely Python, wonderful Python. Um, you know, those are perfectly valid ways to start, and I think you can learn a lot and do a lot in Blockly. I don't know if you know this, but uh, Autodesk runs a thing called Tinkercad. So if you go to tinkercad.com, it's this very, very simple to use CAD program. But part of Tinkercad, there's a circuit simulator. So you can do little circuits, including motors and all kinds of robotic type stuff. And you can do, you can drag in a microbit or an Arduino in that and program it with block code, and then it will automatically translate that block code into C++ that you can then copy into a real Arduino program. And that gives you the opportunity to do something really, really simple in block programming and then see what the C++ is that generates and learn from that while also getting something useful done and being able to copy that into the real world and go forward. So anyway, there's a lot of opportunities there to break into robotics programming, and we should, you know, take them all and not be huffy about it.
Right. Right. Okay, I'm gonna jump back in here and get and kind of roll the meeting. And if there's any more discussion along these lines, we can certainly have that as we go here. So thanks, James. And I know you do some stuff teaching kids too, don't you? Still?
Yeah, I teach a couple of classes
Okay.
for
So
UCSD Extension.
all right. So David might be interested in chatting with you a little bit about that too, because he's looking for something for a.
Well, you know, it's hard to get me to talk, Steve. So
Oh, that's right. You're always so. Yeah. Okay. I won't turn you loose here for the moment. So okay. Well, welcome everybody to the. Let's see. Oh, I suppose I ought to share. I ought to share my screen here, huh? I knew there was. Let's see. I knew there was something that I wasn't doing. And all right, everybody. I trust that folks can see that. Okay, welcome everybody to the March meeting of the Seattle Robotics Society. Glad to see you guys. Well, we got not a ton of people today, but you know, any number of people getting together for robotics is fun. So I'm always glad to see you guys. Miss seeing you in person. Let me tell you, I do love Idaho, and but I do miss the in-person stuff and just being able to bump into you guys from time to time. Okay, let's see here. So our agenda for I'm gonna drop that down there. Our agenda for this month will be pretty much the same thing that we've done all along, and we'll have opportunities to share anything that you know you guys want to throw out there with regard to robotics. Let's see. I think we're all good. Everybody looks like their mics are muted except mine, and I don't know. Maybe I should mute mine too. But anyway, unless you're actively sharing, appreciate it if you just mute your mic so that if there's any background noise or anything like that, it doesn't disrupt the meeting. And I have my chat window open. So if anybody has any questions they want to ask via the chat window, do that. And then also please post anything, links or any other kinds of things in the chat window that will be captured and put into the post, a meeting post. So let's see. Okay, yeah, so this is Lloyd, Chaz, or possibly Donna will be hosts. So there's four of us that actually can host these meetings. So you can pretty much depend on, even if one of us isn't available, somebody will be here the third Saturday. So if you're interested in local maker spaces, there's this website. Makerspaces.make.com or .co rather, has websites all over the country. So you can find them. There's lots of them in the Pacific Northwest where a lot of you are from, but there's other places as well that have them, and cool places. Let's see. There's the Snowco Makerspace regularly does robotics activities and events. So if anybody is at the north end, Snohomish, Everett, South Everett near Payne Field, that sort of thing, they're actually really close to Payne Fields where their Snowco Makerspace is located. So you can connect with those guys, and then there's a let's see, the Robot Events website. I think that's just I don't remember the. It's a pretty simple website. These slides, by the way, will be available as well on in the post after the meeting, or this week sometime. I'll get these things up here, so you can go back, and any of these slides that have links on them, you can access those links that way. Let's see. This Northwest Model Hobby Expo is coming, and I don't see Lloyd on here. There's going to be some SRS folks staffing a table on Saturday and Sunday. So that's going to be this 9 to 6 and 9 to 4 time frames on Saturday and Sunday.
Steve,
And
we've decided to do Friday as well.
Oh, you're going to do Friday. Cool. So do you have some more updates on that? I missed the Robothon meeting, so you want to share anything about that?
Well, we've got at least 2 people for the table for each of the 3 days. That's what we're working on.
Cool.
And, so probably someone will, at least one of us will bring a robot, so we'll have something to show. And,
yeah.
Let's see if people are interested in autonomous robots. I gather that a lot of the expo is RC, control, but we might find some people that might be interested in autonomous stuff too.
Yeah. Okay. And as you can see on the bottom of the slide there, it's located at Evergreen State Fairgrounds up in Monroe. So if that's a place that you don't mind driving to, it's a little ways out there, but it's not too bad unless you're in like Tacoma or something.
About an hour from
Yeah. So these are I think they're just everything. I mean, this is model hobby. So when they say model hobby, I mean it's like you just practically anything you can imagine in terms of hobby activities is represented here at this show. And it's a long, I think, 45th annual, so it's obviously been going for a long time. So and okay, let's see, Robothon. The next Robothon is going to happen at the new field house. So it's about a mile south and a little bit east of where the old field house was. It used to be on 212th and 68th, or a West Valley Highway. It's now kind of off the highway and further south. You can go to the Robothon website, robothon.org, or you can go to the Seattle Robotics website. And I think either one of them, you can find the location of the address for the new field house. So the end of May, there's going to be an event there, and the Robothon website. Let's see if I don't know if we got no. Okay. I thought maybe I had a slide of the contest. We're starting to build up the number of different contests again. So I'm going to try to get those up to kind of get them up to where they used to be. So
I've got a list of contests here.
Okay, thanks, Doug.
Line following, line maze, build challenge number 1, mini sumo, and pop can challenge.
Okay.
And at the lunchtime, Donna is going to do a demo of 3-kilogram sumo.
Okay. Okay, and I think yeah, and then this is going to be an all day event too. I think, right?
Oh, let's see, 10 to 4.
Yeah, 10 to 4. Okay. So, and I don't believe there's what's happened at the like the Sunny Ridge event? What did you guys do for lunch? Did you just people just brought stuff?
As I recall, the last one, Chaz bought us pizza.
Oh, nice.
For sure.
Okay. Well, he's not here, so maybe we could commit him to that, huh? Okay, so anyway, all the information, the contest rules, pictures of the what you would be competing on, all that kind of stuff are on robothon.org. So feel free to hit that. And so I don't recall. Is there a date for the fall event yet? Do you know?
Oh, let's see. I'd have to back out a little bit.
I think the last Lloyd was talking October. I'm not sure if it's going to be early October or something.
Yeah, we haven't firmed that up yet, I don't think.
Okay. Yeah, that was kind of what I'd last heard as well. So okay. All right. So anyway, these are always great fun. If you're anywhere near the Seattle area and you can make it into one of these events, these are cool. So all right. Any other questions out there that I can attempt to answer? Because if not, I will go ahead and roll into the next one. Donna kicked off the Build It with Arduino meetup group last month, and that was mainly a meet and greet, and so it was kind of just had everybody who wanted to share, kind of talking about what they were looking for and their background and all that kind of stuff. So this is something that that she is primarily spearheading, and with the goal of getting more people to do things with Arduinos, and particularly to build robots with Arduinos. But I mean, you can anything that you might be interested in doing is certainly applicable. And so these meetings will happen then the fourth Saturday after. So the week after each of these meetings.
I think it's actually the last Saturday. So if there are 5, it'll be the 5th.
Okay. So so let's see. I think that the last announcement I saw said it was going to be for this month. It was going to be the 22nd. You know if that's still accurate? Because that is what I saw.
320. I think it's nope. I've got 329.
You got 329. Okay. So I'll have to fix this slide then before I post these. Okay. So she's just planning on doing the last Saturday of the month, either the 4th or the 5th Saturday, depending.
Yeah, I tried to ask her, but we never quite got the word in edgewise. Okay.
Yeah. I have a few questions for her too that I haven't gotten answers for. So okay. So anyway, so it sounds like it's if you go to this link at meetup.com, and then go to meetup.com, look for a group called Build It with Arduino, and you should be able to find that, and then that will have the details for that. But I will get this slide fixed so that actually matches.
So for the 29th, she would like us to have an Arduino that we can do something with. So I've never actually had one. So I went to Amazon and just got one. And it turned out that they're, what is it? What is the Arduino, the fancy one? Mega.
The Mega, yeah.
If you get if you tell it you want the Arduino Mega, it says there's this fancy little four-wheeled robot that you get a good deal on. So I got one of those too. So we'll see what.
Cool. Yeah. So I have a handful of both here that I've acquired, and the little robots that I use for these kids classes that I do are based on the Mega. So they have a module that has the Mega inside of it. So it's not quite the same thing as programming with the Mega, but all the capabilities of the Mega are built into this thing. So, okay. So you can find out more information there at the meetup, and I think she's still kind of developing the whole information collection, distribution, access stuff for that. So not exactly sure how that's all going to play out. She's set up a Discord channel for this thing group, and I wish she was here today because she would probably be able to talk a lot more to it and answer questions. But anyway, moving on. Online presenters. We have obviously online presenters from all over the world, and love to hear what's happening and what people are doing in all sorts of different places. So feel free to send suggestions to the Seattle Robotics Society at Gmail, and feel free to reach out. Just reach out directly. If you meet somebody, say, hey, we got this robotics club and we'd love to hear about stuff. Would you be interested in presenting to us sometime? And it can be as simple as that. If you get a good, affirmative response on something like that, say, hey, get some contact information and pass it along to me, and then I'll reach out to them and fit them into our schedule. So we can handle people from probably most places. The most challenging places are Eastern Europe and Japan, Asia, that part of the world, just because of the time zone differences. So it's preferable. Western Europe, we can actually still handle. It kind of ends up being an evening or even a nighttime for them to present to us at our time. But we can certainly handle anything within the United States, from Hawaii, Alaska, all the way to the East Coast, no problem. And so we will would love to plug people in. And obviously, if any of you have anything that you would like to share, projects, something that you do, part of your job, let's say, that you can share with us, anything that can be publicly shared would be great. If you do, when you talk to people, tell them, hey, we record our meetings, we put them on YouTube. So we don't want people sharing proprietary information or anything like that, because then it makes it, we want to be able to share these meetings with everybody. So just kind of let them know about that. I also reiterate that too when I make contact with them. So, and then we have facilitated topical discussions on topics. Sometimes it's just a matter of go out, find a handful of YouTube videos, and we'll just we'll watch the YouTube video. Maybe it's 5 or 10 minutes, and then we'll talk about it. And so happy to have anybody take that on if they want. If you've got some ideas or some particular something that you're passionate about, or something that you want to know more about. So, go out and find some stuff and say, well, let's see what everybody, what people have to say about this. So here's some ideas of things. We've had a few of these things. We've actually had discussions, but there's so much, and so many of these things change so rapidly that if we had a discussion on one of these things 6 months or a year ago, chances are it's changed. New developments, new technologies, that sort of thing. So there's just always lots of options. The upcoming presentation. So today, and I'm not sure if I hope I don't massacre her name, but Dr. Maddie Barasol, I believe. I don't know if there's I don't think she's on yet. So she may come here closer to 11. from St. Louis University. Yeah, I think that's right. Let me see here. I should verify my my facts here. See. Huh, where did I put it? Oh, I guess I believe that's the location of this laboratory, this Mecharism lab. And so she's going to be sharing us about some of the interesting things that they do there, and they're into lots of really cool stuff. So I'm really looking forward to hearing about this. Yeah, interesting. I'll dig some more stuff up here when I get there. So, oops, guess I got to restart that. Okay. Anyway, and so here's the lineup of what's currently on the docket. And my friend John Davis, who talked to us about AI about 6 months ago, last June, a little more than 6 months ago now, he's going to be coming back, and he's going to talk about putting AI on a portable computer. And so I figured that might be something that a few of you might find interesting. And then we're going to hear about the Aloha robot from Joseph Cole, and Chaz Eiler is going to talk about Node-RED for robotics. So, and lots of open slots and lots of places for people to jump in and share stuff with us. We may or may not have a post-meeting discussion depending on how long the presentation goes and how much interest there is in hanging out. But that's certainly an option. But I usually shut the recording off so I don't forget to shut the recording off. So, yeah, St. Louis University. Okay, I knew I had that someplace. So, so I will. So she's going to be sharing with us possibly about probably about the Mecharism Lab and some of the things they do there. But I told her, hey, whatever you want to share with us, whatever you think we might find interesting. So they do a lot of cool stuff. One thing, this little robot down here in the lower left is I have one of those, and played around with that. And I just got it off Amazon, and kind of a cool little thing. Just uses PM DC motors to drive, so nothing special for the drive motor system. But it's got 4 motors on it, and it can spin around, jump around. It's got the ultrasonic sensors on there. It's got a camera. And then it's got Wi-Fi, so the thing can send back to a cell phone or a web browser, and then you can remotely drive the thing, and it's pretty cool little kit. It's like, I think this seems like it was under $100 too, so it was pretty cheap.
That's what I got when the deal, that and the Arduino, and one of the biggest things I liked about it is it has a rechargeable battery.
Yeah, that's right. I'd forgotten about that. Yeah, and it's I have so I think I actually even have one of these kits I haven't built yet. I got them for when I was doing the kids robotics classes with it. I was just kind of trying to figure out what to do, and so I was kind of experimenting. I went and I would get a couple of these kits and just get some different things. And the kids love building the robots. That was probably one of the most fun things. It was harder to kind of keep them focused when it came down to trying to do more programmatic kinds of things with the robots, because that can get for depending on the child's aptitude, that can be a challenge. That their age and where they're at, and it can be tough to keep them engaged when you start talking about that kind of stuff. So I found the block programming is better. Nothing is perfect. Because if a kid wants to learn it and he's willing to engage with it, he can learn anything. But to try to have something that has maybe a little bit broader appeal, is that's kind of what I was looking for, is something where I could kind of take a bunch of kids and have a good chance that most of them will be able to stay engaged long enough to be able to do something interesting with their robot. So let's see, just quick reminder, everything will be, same Zoom link next month. The SRS website will have a post page under past meetings. And so you'll be able to access all the stuff from this meeting. And then I'll try not to take too long. Sometimes I know it's taken me a couple of weeks at times, depending on my travel schedule. So I'll try to get this out this week sometime. Get that post up there, and then I'll make an announcement to the Seattle Robotics .io group. Let you know it's there. Okay, now we can kind of open the floor for cool and interesting things that you guys want to share. So we're just a hair before 10:30. So anybody got something? I see it looks like we, at least for the moment, we lost David, who was interested in some kids robotics stuff. So he's at a show that he said he's there with a film crew. So he's gonna make a video of what's going on at the show. It's in Chicago right now. I'm trying to remember which show he said it was. And I don't know if anybody knows what show is going on there. Hey, Chris.
So I am curious whether or not folks in this organization have talked about Seattle Reconomy before. It's a little bit like a makerspace, but it's actually a tools library here in the Seattle area. Have folks run into that before? So I haven't actually gone and joined it. It's a membership in a tools library. So in addition to having some workspace where you can work, they also have a huge catalog of tools that you can borrow and take home with you for do-it-yourself projects. And it's kind of like a tools rental place, like hammers and saws and ladders and stuff. But they also have the one up at Shoreline has at least one 3D printer.
Okay.
Anyway, I ran into it, and it's sort of conceptually a little bit like a makerspace, but it's sort of got a different class of tools, and the idea that you can borrow the tools and take them home.
Let's see, is that Seattle? Okay. SeattleReconomy.org. Huh. Okay. I've not heard of that before. Anybody else heard of that one? Doesn't appear like it. Well, it sounds like an interesting organization. Any idea what the cost is?
It was kind of on par with the Makerspace membership prices, sort of a monthly $40-50 or something like that a month, kind of thing.
Okay.
I didn't dig too deeply into it because I like I've got a lot of my own sort of tools of that ilk.
Right.
But I just thought it was interesting. They also have classes on shop safety and how to use some of the stuff. Some of the things that I thought might be interesting, there's like hand tools for doing metal bending. So if you don't want to go to the expense of having, sort of big expensive brakes and stuff like that, you might be able to borrow these things if you're making kind of small chassis out of metal. So yeah, I just thought it was kind of an interesting option, and it's super close to me, along with the North Side Makerspace. It's kind of like right in the same neighborhood. So
okay, yeah, I said it. I thinking back in my, now this goes a long time back. I went to high school in West Seattle High School, and back in the day, they had an automotive shop, they had a metal shop, they had wood shop. They had a welding shop, casting shop. I mean, all of these different things. You could go to high school and you could learn how to do all this stuff because they had that stuff. Well, what do high schools have nowadays? I mean, they some of them have some really cool labs. Like if they've got active first teams, that's probably a big plus for getting good stuff into that school. But if they don't have stuff like that to draw those activities, to draw that kind of a tool base, you got a lot of kids coming out. It's like, here's a hammer. I don't know what to do with a hammer. Never seen one before.
Yeah, so I've seen maker spaces in a couple of the local high schools. I think they do a reasonable job of that. Those are often connected with either the First Robotics or First Tech teams. So yeah, those are cool. And I had all of those shops plus print shop and drafting and electronics when I was in high school. So I totally get what you mean about that not being available anymore.
It's kind of too bad. I mean, those were great, because it gave you an opportunity to get a taste for what this was. Because maybe it turns out, hey, this is kind of cool. I want to learn more about it, and I want to learn how to do this professionally. Because there's a lot of jobs out there that are not software, or they're not specifically design and engineering. Let's say there's a lot of things. There's a lot of need for hands-on skills, and there's not necessarily as big of an interest in young people to learn how to do things with their hands, how to build things, make things that the crafts, the craft trades. So we always need it. Somebody, houses don't build themselves. I don't know that they ever will. Maybe, but not for a long time. So you need all the crafts that go along with that. Anybody else got something they'd like to share? Something they've been working on? Going once? No, I'm happy to jump back.
Can I just brag real quick?
Well, I don't know. Are you gonna keep it under an hour?
I'll make it really, really fast.
All right.
For the first time in my professional career, I found a bug in a major robotic arm manufacturer's API library, and they admitted it, and they're fixing it, and I'm super proud of that.
That's actually that's pretty amazing,
right? Isn't that great?
Yeah. I mean, got to have somebody that somebody that looks closely enough at their product and actually figures out, this isn't quite right.
And no, I'm not going to say what the brand or model is. I wish I could. Oh man, I wish I could. They're not like a household name, but they're a big name, and yeah.
Well,
I have to keep a good relationship with them. Put it that way. And some of them might watch this.
So you've dispelled my faith in the perfection of all manufactured things in the world. I mean, I'm sorry. Yes. If nobody has anything else that they want to share, although I'll give you an opportunity here. I've got some short videos that I'm happy to use as discussion starters here. I want to, let's see. We'll do this. This is okay. Well, we'll try this one here. So this is, I'm going to, okay, so I got to get my share. Okay. Let's see. I assume I'm back. So what intrigued me about that, now this had a lot of kind of cool, interesting little features, and you notice at the end there they tried to he took a standard alkaline battery and dropped it in there, and the thing immediately spit that out, and said basically I can't charge that, but and then it apparently doesn't matter which way you put the cells in polarity wise, you don't have to have them oriented properly or the same on top there. You just fill up the little queue with however many cells it'll take, and then this thing will just sit there and one by one charge them and pop them out the bottom. And that's kind of a cool little project. Any other thoughts, comments? If not, I've got a cool video of a Festo gripper. And Festo is one of my favorite foreign companies for robotic mechanisms, particularly animal inspired or naturally inspired robotics. These guys they love to build things that fly, that swim, that hop, that whatever kinds of things they'll use natural inspiration, and then will create a mechanism. And they a lot of them use their cool pneumatic actuators to make these things come alive. All right, let's see here. Share. All right, now tell me you're not impressed.
So those are pneumatic, apparently. You can see the quick disconnects there for pneumatic tubing.
Yeah. I love the, you know, how he uses the triangular gripping, but then they were able to rotate one of those grippers to where you could then grab on either side of a rectangular shaped object or a square shaped object.
Well, they had
But that
6
was,
sites where you could put grippers, and so you just choose which ones you want.
which ones you want. And I wonder, you know, I wonder if the robot has like a like a milling machine or something where the thing could actually select its own implements as needed. You know, I don't know. That
They
would be,
wouldn't. You'd have to plug them in by hand, though.
yeah, I imagine you do. I'm sure this looks like it's, yeah, it doesn't have any of that kind of sophistication. But and then how about the at the very end these long black rubber grippers? You saw how the ends of the grippers kind of twisted around that spherical.
Yeah, curved around the ball. That was pretty cool.
Yeah, yeah, and then at the very end there where it goes and it picks it up and it kind of swings it around. It's like, okay, he's showing off.
Got a good grip on the ball, is what he's trying to say.
Yeah, yeah, yeah. Yeah, I thought that was that's pretty cool. I you know, I bet that's not an inexpensive machine.
But pretty straightforward if you wanted to build your own. I mean, probably nowhere near as good, but much cheaper.
Yeah.
One of our guys 3D printed one of those some time ago using a servo to actuate it instead of pneumatics.
Mm-hmm.
I think you can get a rubbery stuff that you can 3D print with so that you could make those jaws.
Oh,
Yeah, TPU is the material that we used. There's also a nylon, but TPU is a little softer and better.
Oh, yeah. Okay. Anything else? Anybody got something that they just want to share? We got about 10 minutes or so. If not, let's see. Okay, here's a little short clip on a very kind of an interesting sort of a super simple combat robot design. And, you know, I'm sure you've all watched the combat robot videos and the various mechanisms and other things that people have resorted to. And this guy, this is just a little short. It's a snippet out of about a 3-hour video that was made on the event. And this thing is I'll let the video speak for itself because it's okay. What I'm gonna do is get this here.
Robot here called B-roll.
Fun fact, B-roll only has 2 moving parts.
The whole bot.
Yeah.
My name is Peter Lombardo. I'm from Simsbury, Connecticut, and this is B-roll fighting on Team Huge. B-roll is a full-body drum spinner. I like to think of it as kind of a vertical melty brain, where instead of complicated electronics doing all the thinking, I'm just kind of mashing buttons with my controller. I can spin the weapon up and the robot moves backwards. I break the motors, the drum slows down a little bit, and the roll creeps forwards.
B-roll is now catapulting itself across the arena, not able to get under control.
I don't think control is the name of the game for B-roll, and that's okay.
Yeah, fair.
You just got to do the damage, get those aggression points.
I had very low hopes for this, and now here I am at 2-0, and things are going well.
Wow, nice shot there from B-roll. Really weird.
So, did everybody heard the audio from that?
Yeah.
So, it was choppy, but yeah, it was there.
Okay.
So how on earth did he get any wins with that?
Well,
Smothering the other robots or something?
I'm
or just
thinking,
slamming
I'm
into them?
thinking this. Well, yeah, that's a good question. I don't know. Do anybody know how they score on this sort of thing? I mean, are there, like during the match itself? I mean, what constitutes a point, for example?
I thought parts flying off, reduced mobility, and then exploding.
Yeah. Well, if this guy, if he had given enough time, and I'm thinking this thing could very well bring that out of just about any competitor. So
it reminded me of a robot that I saw at the only AAAI event that I went to that happened to be here in Seattle. Um, they had a competition for robots that could do search and rescue.
mhm.
And there was a robot that I think it was probably tracked that would come into the area, and then it would have a row of tubes on either side, and robots similar to the one we just saw were stuck into each of those tubes. And they could shoot these robots out and they would land somewhere. And then each of the robots had a wheel on either side and a little tongue that was mounted to the body that could be retracted with a winch. And so if the tongue was sticking out, then the wheels could push against the tongue and it could get it's a two-wheel robot with caster, except it's just a tongue sticking out. But if it got to some place where it couldn't navigate, there were too much debris or something like that, then it would winch in the tongue, which would wrap around the body, and then it could rotate the body relative to the wheels, which are pretty much stationary because there's nothing to push against, so they get the angle right. And then it would grab on, it must have had a solenoid in it that would grab onto that winch cable, and it would unreel the winch and then let the solenoid go, and the tongue would cause the thing to fly in the air, I don't know, a couple feet high, so that it could jump to some new location and then try and navigate from there. And it also had a camera in it. This was teleoperated. And so they had, a dozen or half a dozen of them on this big robot that could go into an area and then explore it and find survivors.
I'll be darned. Well, if you happen to stumble on a video of that thing, that would be fun to watch. Sounds like quite the. Okay. I got to show you guys this one here. And Doug, you'll definitely appreciate this, but I bet you will too, James. Let me get this one. It's about it's almost 6 minutes now, but let me. I love this is a progression. Actually, you know what? I'm going to leave the audio off because that way then we can talk about this, because it doesn't really have anything going. And maybe some of you have seen this one before. So of course, he's starting off with a book. Okay, what do we do? Well, let's see. Let's go bigger wheels, because then things can go up onto the book. Okay. Well, let's make it a thicker book. Now the wheel can't quite get a grip on the edge of that. So what do we do now? Okay, let's remotor the thing, switch up the axle a little bit. Yeah, not quite. Okay. There we go. Okay. Well, got the front wheels up, but can't get the back wheels up. Okay, now what? Oh, okay, I'm going to improve the tire grip. Okay, well, that worked. Okay, now let's follow books. Okay, front wheels make it no problem. Get high centers. Okay. Increase the breakover angle. Uh-oh. Shift the CG a little bit. Now I make it. Uh-oh. Can't go down, though. Okay. So lower the center mass. This one's particularly clever. So you'll like what he ends up doing to get this one up the way. Now it's no longer able to do it completely on its own. He needs to actually remotely control it in order to get this to work. But I love the mechanism.
Wait a minute. Why didn't he stop there and build a self-righting mechanism?
I think he figured that he could just practice some more and get the thing to work. All right. Well, but for those of us who are engineers, those are fun. I mean, and of course, the really interesting thing being with the transition point where he had to go from letting the car climb itself on its own to where he had to start controlling it. Okay, so that's like, okay, how hard would it be to push that further along? Be able to create something that could actually drive itself over some of those more difficult, challenging obstacles.
Seems like a good place to try out some AI, some machine learning
Sure.
controls.
Sure.
Well, with a much larger robot, of course, his obstacles wouldn't be obstacles, or not nearly as bad. But
Yeah.
then you have a much larger robot, and
Yeah.
pretty much using the largest wheels that they have in Lego.
Yeah.
Isn't that pretty much the solution to everything? Just
With Legos,
bigger.
No, make it bigger.
just make it bigger. Yeah. Yeah.
Hit it harder. Use a bigger hammer. Build it bigger. Not to being very careful to completely ignore part of this story and just focusing on the one tiny little bit. I really enjoyed watching the largest Scara type robot arm that has ever been made catch a booster out of the sky again this last week. That was a lot of fun.
Wow.
I don't know if you guys watched that, but
No, I should have. Yeah, no, that's what I should have had a video clip of.
yeah, well, it's pretty cool because it is in fact a Scara arm, right?
Yeah.
It really can open and close the arms and move up and down and move left and right. It's absolutely amazing.
Wow.
I'm trying to think of other things to use that for, like I don't know.
Yeah, something that can, an arm that can catch a rocket booster out of the air. What else could I do with that?
Actually, I was thinking about this. I wonder if any of the port cranes are automated or if they're all manually operated. Because I mean, that's my thing for robots is they have to be like the robot has to be making the decision and doing the work.
Right.
So I wonder if any of those huge port cranes are automated. I know that a lot of them are like operator assisted, but that would be another one. Wouldn't you love to be able to program a port crane?
I think there's quite a bit of automation outside of the U.S., especially in Asia, but in the U.S., the unions forbid it.
Let's see. Okay, so let's see. I'm just gonna. I guess I should make the ask here. If there is there anybody online at the moment for Dr. Basel? Or is it Basel? Okay, I haven't. Well, let's take a. I need to visit the restroom myself, so we're gonna take a short break here, and I will actually I will reach out to her and make sure that she is coming. So feel free to continue to chat if you like, and I will be back shortly.
So, James, I think far more impressive than the arm that can catch a rocket is a rocket that can get itself to the arm without blowing up.
And that is also a robot, isn't it? I mean, it's given a job to do and it makes decisions and changes its actions and moves on its own in order to accomplish that. It's too bad the other one keeps blowing up.
Exactly.
Yeah, the booster's pretty darn cool. I'm always very appreciative of Gwynne Shotwell's excellent work at SpaceX.
It's amazing how far we've gone in such short a time.
And then the other one is, wouldn't it be great if they could make a robot that, well, I guess one of them did. Yeah, I was going to say that lands upright. Scott Manley had a good video out about the Thinking Machines. That's the name of the company, right? They're
falling over on the moon
again.
Yeah.
So sad. And apparently it was, well, we know from one of the pictures that there was a broken landing leg. So and it appears from the video that it was traveling sideways, which typically, if you're landing on the moon, traveling sideways is not a good idea, unless you're like, I don't know, like a skid type lander. I do. Are there duck landers? I'm thinking of the way a duck comes in and lands on a pond. But anyway, that doesn't work if you have landing legs. So apparently it came in sideways and broke a leg and landed on its side. So, my thing is it's probably another software error, which software errors in robotics, it just hurts the soul.
Yeah,
To
and
be
it's
fair, it did land sideways autonomously.
tough to test under the low gravity situation that they're facing.
Turns out living in a gravity well has its downside. And as roboticists, like, we know how hard it is to get the software right. Well, I don't know. I mean, as a software programmer in robotics, anybody who has written software for a robot knows how hard it is to get that right. And it leads me to think about this whole thing where human beings do a really bad job of guessing how complicated or how hard things are, because, like, if we can do it, like move gracefully, some of us, not me, can move gracefully, then we think that must be an easy thing to do, when in fact we are utterly amazing and we don't appreciate how amazing we are and how difficult it is to move sideways. And then things that we suck at, like leadership or controlling ourselves or cooperating with each other, we think are super, super hard, when they're actually, I think, pretty easy. I mean, I think you could maybe write a program that could direct everybody on what to do, and it would ensure that everybody worked together and we would accomplish great things. So the point I'm making is we have it flipped. Like, we think robotics is really easy, but it's actually really hard. And we think that cooperation is really hard, but it's actually really easy. Anyway. In case anybody didn't catch it, what I was going for there was humans are great robots and machines are great leaders. That was meant to be a controversial statement, and I expected somebody to scream. So. No screaming. Everybody just agrees with that.
Are you anticipating like Leader GPT, that you just do whatever it tells you?
That's exactly what I'm saying. If you haven't, Marshall Brain wrote a story called Mana that has 2 parts, and the first part of it is basically just about a program that runs a company, and it does a great job of running a company. It's very repetitive, very like day-to-day operations would easily be automated, and you could do a better job of that. And I think some people who have worked in big companies that use software to help manage processes can see that it should be applied in more places and it would work great. So yeah,
like having software fire 1,000 people by email. Not that I ever worked for a company that did that.
Yeah. I mean, that's at the direction of the higher leadership. I'm thinking about, like,
is it
replacing the higher leadership?
Well, higher leadership often gets there by being connected and rich. How are you going to replace them, on accordance with just saying that something else could do a better job? What's that got to do with it?
Yeah, that is a point, he says, standing there with his pitchfork and his torch.
As a retired manager and software developer, I always preferred the computers over the humans, because the computers aside from the bugs, always did what you told them to. The people rarely did.
It's very true. I mean, the annoying thing about software and robots is that it does exactly what you tell it to.
Well, also, I mean, are people going to start programming AIs to carry grudges and engage in office politics and sexual harassment and all the other functions of management?
Already done.
They learned it from us.
Actually, I read an article to the effect that when people instructed coding GPTs to write bad code, they also became racist. I'm not really sure what the connection there is, but
Yeah. I mean, I feel like it would be possible to write code, either classical AI or even just train and one of the newer transformer type AIs to do a good job of running, at least running a company, if not running a government. I feel like that's more. I feel like that's an easier ask than trying to make a robot that's humanoid and has the same kind of dexterity and ability to manipulate things that humans do.
yeah, the
Although
difference
I
though
will
is that
admit we're getting very close to that.
if you could make a dexterous robot that you could use to replace irritating workers and it would save you money, it would be easy to get them installed. No matter how competent an AI was at running a company or a government, you'd never get it installed.
Yeah, no, you're absolutely right. That I think that's really the crux of it. That's why I'm saying is we have it backwards. Not that it will change, not that we can change it or that we should change it, just that we're doing all of this backwards.
Well, it's also the theme of any number of sci-fi stories to the effect that we realized how much we suck at managing things on a large scale, and so we installed AIs to do it. And the AIs took one look at us and decided we could be dispensed with because we suck too.
Right. Going back to, well, I was going to say Colossus, the Forbit project, but I guess they didn't really dispense with us there.
Well, I hardly think that they would use us as batteries in the Matrix.
Yeah, that was a little ridiculous.
Somebody didn't do any math.
Yeah, it's actually kind of interesting to me because most of the most popular science fiction, even that's been made since post ChatGPT, doesn't really address AI in any kind of a reasonable way. I think there were a couple of episodes of the original Star Trek that weren't bad. There's one about a computer that has issues on the Enterprise, and there's stupidities about robots breaking down when they're given illogical things to try to compute.
But a lot of sci-fi is only sci-fi because they say space in front of everything, and it's always an allegory for some social problem,
Right.
For race identity, for gender identity, for whatever sort of identity is being persecuted, and making the point of if only we changed the names a little bit, it would look ridiculous. So why doesn't it look ridiculous the way it is now? So people like AI is not an identity, so people aren't that invested in it. Maybe.
The one I really love and the one I like to point out is Dune, the original books, because he straight up banned any kind of automation in those books. They had it is mentioned, not in a super obvious way, but it is mentioned that they banned all of the machines because of they had risen up against humanity, which I would call an alignment issue, not really a revolt, but just, we gave them a goal and they carried out in a way we didn't expect, probably.
But whose fault is that?
Exactly. Yeah. And then they were just banned. Like, you can't have that. And I think that's got to be the only science fiction series where they've ever done that. I'd be really curious to hear if there was another one that followed that approach.
I can't think of one off the top of my head. But at least they had a replacement, right? They had Mentats. How do you go to Mentat school?
Yeah. Yeah.
At least in Harry Potter, they send you a letter by owl. Do you get invited to Mentat school, or do you have to be recommended, or you just sign up, or what? Or do you have to be born into it?
Well, we know in Dune they certainly had a lot of testing of children.
That's true.
Paul got to put his hand in the box to see whether or not he was an animal or not.
But I'm not clear that everybody gets that test. I think Paul was in a kind of special circumstance because of who his parents were.
Right. You can just imagine that they did some other form of testing for that. But anyway, I think the subject of robots and AI in science fiction is really interesting because it's so rarely addressed in a way that makes any sense to those of us who kind of understand the industry.
Well, right, but also they don't go into the tech that much. Like robots are pretty much an allegory for, is it okay to keep slaves and how you treat them?
Yeah. Data was certainly that was his whole thing.
Yeah. Well, and I suppose that's something we will have to worry about when we get to the point where we think, GPT and whatever has achieved artificial general intelligence. So does it have rights at that point? Even if it doesn't have feelings, are there ethical obligations about how you treat it, how you use it?
Yeah. Well, what happened to the guy who raised that question at Alphabet? He doesn't work there anymore.
Yeah.
There are these difficult questions that people don't want asked.
I think it's more that they don't want them answered.
Well, the point is, if you don't ask them, they can't be answered.
True. But I think really the issue was, if we don't like the answer, did we just waste how many $1 billion?
Yeah. And that's one of the minor problems with the way that we're crashing forward. What's the story about the biology professor who says that if you're doing a field trip, you must always walk far enough ahead of the group that you can step on any specimens you don't recognize before one of your students asks you what they are?
Wow, I hadn't heard that.
Oh, this is what we're doing right now with AI and robots.
That's probably true.
Quashing the question so that it doesn't have to be answered.
Seems like that person would be able to publish in some other venue, though.
Haven't heard a peep from him, have you?
I haven't, no. But I admit that ethics is not one of the subjects I'm most interested in.
Like all of us, we're just working on robots and AI and bringing it around, because what could possibly go wrong?
Well, my own use of AI isn't to train new ones to do horrible stuff. It's mostly to use it to help me learn an unfamiliar programming language and get up to speed quickly by making it so that it can answer obvious debugging questions that I haven't learned how to fix yet.
Yep, that's pretty much my thing too. Although
Yeah.
I am working on trying to train an AI to do better motions in robots, which is a really interesting and I think underappreciated possibility. We'll see how far I get with that.
Well, I'm more interested in being able to use AIs as a smart manual right now, because I find myself working in a whole bunch of different languages and systems that I'm stale on. And so I ask it questions about syntax. I want to do this in this language or this environment. What do I say?
Yep.
Or I give it an example of this is what I want in pseudocode. What's the syntactically right way to say it in here? And it gives it to me. And so it saves me time.
Which one are you using primarily?
At home, I'm using what I assume is ChatGPT. At work, we have a subscription, like a Teams one. And I've been experimenting with something called YeCoder, which is running on LM Studio on my own machine. It's way smaller, but it's not much slower, and sometimes it's better.
Interesting.
I
If you
actually
want
have
to
a
post
side
a link
project.
to that, I'd be appreciative. I'm curious about it. I've
I'm
actually been using Gemini from early on, and it started off pretty bad, but it's getting really good these days. I'm super impressed with it. And what I like the best about it is it gives me links that actually apply to good resources, you know, from their corpus of search data. So if I want confirmation, or if I want more information, or if I just want to be able to reference where I got that idea from for the future, then I can follow the links. So yeah.
Well, I'm in the kitchen cutting onions on my iPad, so a link isn't really in the cards right this minute. Unless you want a really onion scented one.
Smell-o-vision hasn't happened yet.
Actually, I read about some product where they're anticipating being able to.
It was Sony, and
they were talking about a taste one also, which, like, I don't know, like, what do you put it in your mouth? You know?
I just don't see that happening. But they come out with that about every 5 years, every 10 years. There's another round of it. Us old whitebeards will tell you that is an idea that just keeps coming around and then keeps not being done.
Well, I mean, the issue is that it's not like they can combine 3 scents or 3 tastes and get the whole range. Right?
No,
I mean,
it actually, I think, if I remember correctly, there's like five different things that you can get to a semi-close approximation of pretty much any flavor. I think it was more than that in smells.
Yeah.
But yeah, it isn't that many.
So think about what we've got now. If we've got a device which can create smells and tastes, and we use 3D printing to give us something that is representative of what it's supposed to smell or taste like. Now consider how that compares to what was it? Brazil. Brazil, where they had in a restaurant, each of the people would get a dollop of glop with a photograph of what it was supposed to be. But you could imagine that dollop of glop having 3D printed form and smell-o-vision smell and taste-o-vision taste.
I've forgotten that scene. Thank you. I'll have nightmares about that tonight.
I think the tariffs will rule out the possibility.
Well, and then you could have nutrition independent of smell and taste. So you could decide to
isn't it already
something that is filling, and so you lose weight, but you're eating just what you'd like to taste and smell.
I know a guy, by the way, who has a 3D printer that he's adapted to print with granules, which is a lot harder than it sounds. And he has 3D printed with sugar, actually melting it or caramelizing it. So if you like creme brulee,
that was done pretty early on with the laser-based ones. They did it with that, and there was somebody who was using focused light to melt sand as the powder bed.
Yeah,
So you would have these really ugly glass-based things, basically.
This one is extruded FDM, and it comes out pretty good. I'm trying to find the video now. I'll post a link to it if I can.
Or you could play the video if you wanted to. Just an update on our presenter. It doesn't look like she's going to be able to make it. So she's in St. Louis, Missouri, and they had a tornado. She says a tornado went through. They had golf ball size of hail, and it knocked everything out. So they got no power, they got no internet. They're just dead in the water. So I will reschedule her, and but we this is what we got, so we'll just keep chatting here, and I'll cut you guys off. I don't know, 5-6 o'clock tonight, right?
Well, there's a link to that video if you want to see it. The video is probably worth playing at least part of, just because this guy's accent is absolutely fantastic. I just love it.
Priorities.
All right, let me cue this thing up.
And he's, by the way, just seriously an absolutely brilliant person. Everything that he makes looks like it was like cobbled together with bubble gum and rubber bands, and yet it works. And I make things. I'm a horrific fabricator, but I make things that look very, very nice and don't work at all. So he kind of ticks me off that way, but I am in awe of his ability.
All right. Well, it looks like the video is only about 10.5 minutes long. So, but just start at the beginning.
Yeah.
Okay. Audio.
He does a lot of robotic stuff as well. So.
Now that I'm sure that version 3 of my extruder prototype can handle PLA without any problems, it is time to test new materials. A raw material with a suitable grain size, which is available in almost any household, is sugar. So let's turn on the printer and check the temperature needed to melt this material. According to the display on the printer, this is the case at around 170 degrees Celsius. It can be seen that the grains change from solid to liquid almost instantly. This video sequence shows the real speed of the process. So let's put that exotic 3D printing material into the hopper and heat up the hot end. As soon as the dial temperature was reached, I started the extruder motor to squeeze the sugar out of the nozzle. However, this looked very different from the way PLA exits the extruder. Instead of forming a sugar string, this material drips out of the nozzle like water. This is because of the significantly different chemical composition, which corresponds to very different physical properties. Sugar is the generic term for a whole range of different, sweet-tasting substances. The household sugar used here consists of sucrose. I swapped the conveyor screw for a wood screw without a wire at the tip, because the helical ridge must dive deeper into the melting zone to properly forward the sugar grains. In the third attempt, the printing finally worked. I'm using my universal cure for bed adhesion, my cheap glue stick. The file to be processed is the small gear on the stepper motor of the extruder. The temperature of the hot end is set to 181 degrees Celsius. The print speed is 10 mm per second. As you can see, a color change occurs in the hot end. The sugar exits the extruder in a slightly brownish color. The reason is the caramelization reaction that takes place at temperatures above around 140 degrees Celsius. A pleasant smell spread in my video studio that made me feel hungry. The top surface of the gear is not as smooth as when printing with ordinary plastics. The reason is the surface tension in combination with the significantly lower viscosity of the molten sugar. The tip of the nozzle is always surrounded by a drop of liquid sugar. With that, it is surprising that the only 3 mm small teeth of the gear become clearly visible. The tiny gear is far from being perfect, but not too bad for a first try. At the top, the tendency of the liquefied sugar to form droplets can be clearly seen. On the other hand, however, you can also see the layering of the print. For the next attempt I use a sugar solution for better adhesion on the print bed. The brown color of the solution comes from the fact that I also dissolved a piece of the gear printed before. To make the water evaporate faster, I set the print bed to 80 degrees Celsius, which is the temperature I used during the following prints. First, an octagonal base plate with a diameter of 100mm is printed. The sugar now sticks much better to the print bed. Again I started with 10mm per second as print speed. During the first layer I increased the speed to 30mm per second, which still works well. When assembling the extruder I forgot to seal a gap on the inside with adhesive tape, so sugar grains keep falling out of the hopper. At 30mm per second, the handmade extruder prototype starts getting louder due to vibrations of the mechanics so that the sugar trickles down.
Don't you love his voice?
The base plate is printed nice and smooth at the higher speed. Now you can see strands of printed sugar on the surface. Obviously, the melted sugar has no longer enough time to form droplets before solidifying.
So you can skip through this if
The
you
next
want to,
step
but
is to
I mean,
print 1.8mm thin walls
good
on the
stuff.
1.75mm. So in the next test run, the print speed was set to only 10mm per second for the walls in order to keep the vibrations of the mechanics low. If the base plate is also printed at this low speed, it becomes just as bad as with the gear wheel. Here too, sugar droplets will form on the surface.
So there you go. You can
With the
for
reduced
whatever
print speed, it can be seen
sort
that
of
caramelization leads to darker color.
flavoring that you
The
want
walls
in
are
there,
amber and no
and then
longer
put a
quite as
picture of that
transparent.
flavor next to it, and serve that up on the plate as fine
Again, a
dining.
drop of sugar forms around the tip of the nozzle. The individual strands cannot be seen on the upper edge. The individual layers in the walls, on the other hand, can be clearly identified. There are 50 shades of brown in the different layers. The handmade extruder has
50
so-called
shades of
back
brown.
spots, which are corners in the extruder where the sugar stays in place a little longer until it is flushed out of the nozzle. Longer caramelization leads to darker color of the sugar. All in all, I am satisfied with the result. The walls are quite smooth and no cracks can be seen anywhere within the layers. The extruder seems to convey the sugar fairly consistently. It's nice that the transparent sugar walls also allow a view on the inner structure. With a print speed of 10mm per second, it seems like the printer has no problem with the brittle material, so let's try 20mm per second.
You can also see too that the sugar is being pulled towards the
Obviously that
center
works fine,
because
good.
the head is on the outside edge all the time, and it's like the sugar water is like
Only for
sucking
a
it
few
back.
layers. The
But
printer has not
unfortunately,
yet started
it is
to
very
print rough
bright.
edges, but shortly after increasing the print speed, a piece of the wall broke out. This happened when
Anyway,
the
in his other videos, he goes on to
obviously due to the increased printing speed,
and
tiny
before
dents
this one,
built up in the
what he
walls
was
while the
doing
sugar
was
was.
3D printing with ground up plastic.
This has also
So
been
he's
shown before.
like doing the actual like the holy grail thing of taking a failed 3D print and grinding it up and then just
After the
putting it
bed,
in the sieving it so that all the pieces are the same size. And then he puts it back in the hopper and he actually
an
3D
attempt
prints
to
it.
print the base plate with the
So
heated bed turned off also
pretty
failed.
amazing work from this guy.
With that, cracks formed in
And then his other big project is he runs an entire like set of little robots up in his attic, and you can teleop remote into those and run them around. Pretty lousy user interface actually, but it's still kind of fun. He has like I don't know like 5 or 10 robots up in his attic that people remote into his house and run them around all the time in this little like world that he's made in his attic.
Well, that's pretty cool. So it sounds like he just recycles the sugar material rather than eating it.
He does say somewhere in that video that he doesn't feel like it's that it was printed in a way that's like safe or edible or whatever.
I didn't find I would not have really wanted a taste sample of one of those. So
I would have, because I love caramelized sugar. I think it's great. The other one is a guy that I met a few years ago at Maker Fairs. And I actually got to teach a short class at Grumman locally on G-code, which this guy made a pancake 3D printer. So it extrudes pancake batter onto a hot plate to make pictures in the pancakes. And by controlling what part of it gets printed first, you get darker lines or lighter lines. So it tends to extrude the outline part of the batter first, and then go back in and do the fills afterwards. And you get these little thin pancakes that are completely edible. And so anyway, they had one at this local Grumman office, and they asked me to come down and give a talk, and I did a talk on like how to hand code G-code. So that they would understand what's going on inside the 3D printers. And we made pancakes, mostly just squares, because that's easy to hand code. But so that's another 3D printed food thing that I've had fun with.
I went to an engineering open house at Boise State University, and it was kind of geared for kids K to 12, and took a young friend of mine there, and there's the engineering school there has this really cool. The best way to describe it is it's an adult toy shop. I mean, they've got tools for everything, tools to make everything. They'll teach you, they've got bending brakes. They'll teach you how to weld. They've got they can do compression and tensile tests on specimens. They test concrete in particular, because one of their contests that they do is a cement boat. So people, students design and build a cement boat, and then they race them. And
love
so
that. That's just great.
And they were giving away these nifty little 3D printed things. They got about 20 of them on a shelf, and they were all just cranking all kinds of different little things out. This was a little, I guess I suppose you could call it a snake or something. It's a single, something that was done in a single print, and then it's got the little linkages between each of the body elements of the thing. So it's flexible and but it did not have to be assembled or anything. It was just printed this way, and then I'm guessing they must have to just kind of carefully get each of the segments moving once the thing is done printing. But it's a pretty cool little thing, and it's got the kind of cute little bug eyes on it there. But it was
love it. Is that twist that it has to it? Is that by design, or is that just the way it came out, or the way you were holding it?
What was the question again?
It looked like the body had a kind of a natural twist to it. Oh no, okay.
It's pretty flexible. See, I can take that thing and I can wrap it into a pretty tight little circle. So it's natural.
No. Like there was an axial twist to it while it was hanging there.
Oh, well, it turns out. See, so if I take, so you're looking at the bottom of it right now. Now you can see the top of it coming around. Now I've twisted the tail 180 or 360 degrees now. So the tail has now been twisted around completely, one entire revolution.
Now, if you twist it and then just let it go, does it stay there, or does it want to rotate back?
It wants to rotate kind of mostly back, because there's a little bit of a twist there, looks like.
Yeah, it's interesting. I wonder where that comes from.
Yeah. Huh.
If you twist it up, does it get shorter?
let's see. Okay, so yeah, well, it looks like, see how it's kind of curling in the middle there, bending. Yeah, so definitely.
So its own weight should straighten it out, but there could be friction, that would stop it from being exactly straight.
Yeah, I think that's what's going on. Yeah. And it's, it's a fun little fidget. I mean, these kinds of things are just cool. I don't know if anybody else has any cool little 3D printed things. When I was working at Boeing, I worked with, around people who worked with a lot of different things, stereolithography machines, which are the liquid resin, laser cured liquid resin machines. And they could make big things, I mean, these machines could produce huge, big things out of this material. And they always had, and they'd always have samples of things around the lab there that you could take. So what are we looking at there, James?
Oh, somebody was talking about twisting things. I don't remember if have I ever shown you guys this? This is it's probably hard to see in the video, but there's a motor up here. Let's see if I can show that at all. It's a really lousy little DC motor, just a piece of junk. And there's a string tied to it that comes down like this. It's this little green, I don't know if you can see that right there.
Okay, yeah.
Green string. And it comes down here to the bottom where it attaches to the bottom of the drawer slide.
Okay.
Oh.
And the way that it's attached at the top is there's nothing exciting about it. It's just attached to the shaft of the motor, so that when the motor spins, it twists the string, right? Now let me see if I can get a power supply hooked up with a set of wires here. I'll show you the bottom so you can kind of see what actually happens here. Let's see, I can turn it on. There we go, a couple of volts. So when I attach this, you see that? Pull it up there. And then if I do it the other way, you'll see it go down.
So show us the filament as when it's all twisted up.
This is the filament right here.
Right, but it's above where your camera's aimed.
Oh, you want me to move the camera up?
Yeah.
So I mean, there's actually kind of nothing more to see. It's just, there it is. It's just all twisted up. And then if I reverse the direction, what you'll see is, I'm just pulsing it, but it goes back down, and then you'll see it pull the drawer slide back up. There's a little bit of release. You can see, like when I let the power off, I'll see if I can hold it so you can see. So I'm attaching the power.
There's a toy that consists of 2 strings and a button, and you thread the strings through the button, and you hold the strings on either end, and you pull. Actually, you have to spin the button a bit to wind up the string, and then when you pull on it, the wheel spins and continues on.
Oh yeah.
So it's pretty much this, but using the additional bit of but you could imagine like winding up one and not the other side of the button, and the button then would move side to side. So that's pretty much what you've got there, except you're using gravity.
Yep. So this is my other horrible fabrication work, where I've 3D printed a pulley, put it on a stepper motor, and I have a belt for it. And then I need to mount this and then put another 3D printed pulley on this flange right here. And then that holds an encoder. And the encoder is based on this guy, which is the laser cut encoder that gets, this one is producing about 160 thousand clicks per revolution because of the optical, analog optical encoding between each one of the slits. So this is then going to be, I'm working on this as the servo implementation using that same technology. And I have a premise regarding that I need to test to see whether or not it's true, which is that the delay caused by a lower resolution encoder swamps all of the other elements in the control loop and makes the, like for example, if you're using a simple PID controller, it makes the I and the D terms important. And if you remove that delay and have a fast speed loop, then the I and the D terms fade away, are no longer necessary. And you can just do simple P control, which is really nice because then you don't have to do a ton of tuning on it. Anyway, that project is progressing way too slow because I'm an absolute horrible fabricator. But that twisted string actuator that I was talking about before, I feel like that's really overlooked. I've made like a really big version of it here, but it has been made, it has been used to make finger actuators on a robotic arm, where you have like a bunch of little fingers and the motors are up near where the elbow would be, with these strings that then go down and go through a guide and then go into the fingers and pull them back and forth. And you can get just a ton of different degrees of freedom there. I think the one that I'm thinking of has like 12 degrees of freedom. Oh no, it was more than that. It was like 20, which is exactly what we do in our hands with our fingers. The tendons go back up to the muscle, which is in the forearm. It's a different method of actuation, obviously, but think about how cheap that is. It's a little pennies motor.
Well, and it takes very little room. Basically, you're replacing a gear head and a worm gear with just connecting the filament directly to the shaft.
Yep, exactly. And what's interesting to me is that there's always this question in my mind whenever I run into something like this, like, why isn't this done? Like, why isn't this everywhere? And I think the reason is that early on, a lot of the research that was done in this was done with monofilament fishing wire, which is a really stupid choice because monofilament fishing wire isn't designed to be twisted. It's designed to be pulled. And so what I was using there, what I'm using, and what I think should be used is what I'm specifically using is called spider wire. And it's a woven fishing line, tremendously strong. But because it's actually woven out of smaller filaments, it's already twisted. It's designed to be twisted, if that makes sense. So I think the lifespan of it will be hopefully far better. I know I left that running for quite some period of time, just with a little controller that was, running the motor one direction, then running it the other direction, just a small delay in between each one. And it ran for quite a little while. Doesn't seem to have any wear on the string. And you know what? Who cares if the string breaks? It costs nothing to replace it. So it just seems like it would be an interesting thing to try.
I just found this a little short, about a 1.5-minute video here called "Impedance Controlled Twisted String Actuator."
Yeah, that's a good one.
Yeah.
I have another one somewhere. I'll see if I can find it really quick if anybody's interested. Okay. I don't want to.
Let's back this thing up here. Okay, let me go ahead and share this one.
Well, they're using a spring. So they're actually using like my button idea. They have a couple of strings that are. Now you can imagine linearity, but I wonder if you get repeatability or vice versa.
Yeah, it's a force-based mechanism. It doesn't work like at all for positional control. You very much have to have a position sensor and then do a control loop. Pretty cool though, huh? This is a link to, I posted in the chat a link to one about a hand that's run with twisted string actuators.
Okay, see how we're doing. 10. Okay. Let's see here. Cue that one up.
Yeah, and they're showing a little bit more about the calibration and about getting some position feedback involved in it, doing a better job of it. You probably skip forward a little bit. There's some good videos of the. Oh, well, here he's showing the tension enabled figure. So that what they can do is they can sense then where the how much force it's experiencing, and then they can regulate based on that. And changing the modes. They like this thing where they change from speed mode to force mode.
I'm trying to figure out why the string extends from the central gear to the left there.
So what they do with that is by breaking that segment or not breaking that segment, they allow it to twist at a different dimension, if that makes sense. So like it does a very, very fine twist if that can spin, and it does a very coarse, wide pitch if it can't. So that, like, you can see this is the what they call the force grasp mode, which is where it's a finer twist, and therefore you get more pulling force at lower speed. And then that was the fast motion where it's doing the coarser, wider twist where it moves faster, and then they can change it so that it moves into the higher torque. That's just kind of an extra also then or whatever.
So is it done with two different motors?
No, it's there's just the one motor, which is the big long cylinder out the end. And then the one in the middle is a clutch. So it's basically being allowed to spin. It's that, like that button one that somebody was talking about. Right. That's being allowed to spin, or it's not being allowed to spin. So you can see, I mean, the advantage of it is look how fast that is, right? Yeah. And then at the same time, they can transition over to like what they call the force mode by releasing the clutch and letting it spin at the finer diameter, and then they get the ability to pick up like a 7-kilogram mass.
So he was using a strain sensor that was sensing his hand in order to be able to use his hand to control it, basically.
I honestly didn't catch that. I think I think the strain sensor was actually being used to sense the amount of force on the finger, on the mechanical finger, but I could be wrong about that.
No, but what I mean is back when he was grabbing, I don't remember what it was now. Previous part of the video there. Anyway.
So they use this to make some pretty cool little things. One of the things that's nice about it is that
there,
it
see,
actually takes up so little space.
On his left hand.
Yeah. It takes up so little space that you can take a person who has a hand but has no strength in their hand.
Right.
And then use it to actually increase their strength.
Yeah, so you can see, so it looked like he had a glove that allowed him to. So that last part of the video there, it said that I'm guessing that there was the guy with whoever was wearing the glove was out of sight.
Yeah.
Yeah, I think the guy who wasn't holding the hand was controlling the fingers, which is kind of funny. Anyway, there's a lot of if you search for twisted string actuators, you'll find all kinds of just really completely amazing stuff.
Yeah, that's pretty cool. Well, it's coming up on noon here. See, I knew you guys have stuff to talk about, so.
It's trying to shut him up. That's the trick.
You're giving up on that. Of course, I guess, I don't know, there's always this, so. Just click the little button up in the corner there that says mute.
Oh.
Okay. All right.
See, so I don't know. Do you have one of those for me? Can you
no, I don't think I can mute you. You're the host.
Yeah, okay. See, so I have power.
That last video that I posted there, not that you want to display it, but just to explain what it is. That one, there's a really long introduction, and in the middle at 28 seconds, it shows this arm with like the actuators all way back in the back and the strings going forward and then going into the hand, which I think is a really intelligent way of doing it.
Okay.
That sounds like a really good technique for a Lego implementation.
Yeah, why not, right? You could do some really cool things with little like DC motors and Legos and play around and have a lot of fun with it.
Lego has gears with holes in them, and it has string.
Right. So it looked like there's kind of two different ways you could I saw two different implementations there. One of them is like just taking a single string, and twisting it, or taking a pair of strings or a trio of strings and twisting them. So do you get more displacement per twist if you have more chords?
It's I think it was more about balancing the force, because like two strings, what's the word I'm looking for here? Like if you have just two strings, then when they're going through a button and the button is twisted, then it can get stuck in the twisted position. Whereas if you have four, then there's more rotary force. The more strings you have, the more threads you have, the easier it is for the thing to rotate, or to cause something to rotate. I don't even know how to say that. I can see it in my head, but you can't see what's in my head. Thank God.
Yeah.
What's the thing that's rotating in what you just said?
The button thing that changes the gearing, basically. The thing that goes between the coarse twist, which they called speed mode, and the fine twist that they called force mode.
I suppose you could imagine a variable friction clutch there, so that you could get a fine.
That's exactly it. You nailed it, Doug. That's exactly what they're doing. So if you look at it, it starts from the motor, it comes out to a button that's spun by the motor,
right.
And then there's a relatively large shaft, and then there's a button that has a clutch.
Oh, so there are two buttons. Okay.
There's two buttons. The one that's spun by the motor, and then the one that's further down that has a clutch on it. And between those two, there's a relatively large shaft. And then as you go down further, past that second button, then there's basically no shaft or very thin shaft to twist about. And so if you clutch that secondary button, then the motor button twists around the fat shaft in that short space between the two buttons. And that just really yerks in on the cables and is what they call the speed mode. And then if you unclutch that second button, then it spins with the motor button, and it doesn't twist around the fat shaft. It twists around the nose shaft that's downstream of the clutched button.
Okay.
And again, you don't have to do that. You could just, like I did, just put the freaking string on the motor, and it's a little bit slower. Then you don't get the high speed mode. You actually do, because what happens is, as it pulls in, if there's a resistance, and your motor is strong enough. I don't know if you ever built a balsa wood airplane with a rubber band propeller, and you twist the propeller. What you'll notice is that
the rubber starts to build on itself.
Exactly. And so you do get two different speeds. They're just not necessarily what you ideally want for the application.
Mm.
Well, it's been fun.
It's been real and it's been fun, but it hasn't been real fun.
Oh, yes. All right. Well, I'll get our be able to get our professor on here. Maybe in July. I guess we'll see what her schedule looks like out there. I think originally contacted her like a year ago. So I've been trying to get her on for quite some time. I think she's got some interesting stuff to share with us. Hopefully.
What was her talk actually about?
Well, she runs a place called the Mecharism Lab. So she says that the description here says we engineer the future by integrating mechatronics and algorithms to create innovative solutions in assistive rehabilitation, agricultural robotics, enhancing lives and advancing education. Let's see, they got to release an article in February here, robotics action through large language models and natural language processing. A transformer-based model for enhanced motor intent recognition in assistive robotics. One of the projects. It looks like the lab itself, they do a lot of things in trying to maybe building prosthetics and things to help people that have physical disabilities to be able to function more normally.
Cool stuff.
Yeah, I mean that's always pretty fascinating. I mean, $6 Million Man. Remember that back in the day?
Don't get me started.
I know. I wasn't even barely a teenager when that show came on, and
Jamie Summers was my first crush.
Yeah. Yeah.
You better treat her right though, because she can rip a phone book in half.
That's right.
And not just a few pages at a time.
No, the whole thing.
Yeah, that was.
And you couldn't cheat on her because she could hear you.
Exactly. Yeah. From like 2 miles away, So.
But why would you want to anyway?
Yeah, exactly. I mean, my goodness.
Yeah. Anyway.
What was the Lindsay Wagner? Is that right?
Yeah, Lindsay Wagner.
And then the other guy was Steve Austin, played by
Lee Majors.
Lee Majors. That's right, Lee Majors. No.
I love the robots that the villains would create in there. You remember? You can find YouTube videos of the little fight between him and one where John Saxon was the actor playing a robot who was like
right.
Yeah, an old buddy. But then that old buddy was, I don't know if he was killed and replaced by the robot or what it was, but and there's this battle, and then the robot, they're playing on this hillside and Steve finds this girder, just happens to find this really handy pointed I-beam girder on the ground and lifts it up, and the robot jumps off of the hillside above him and then impales himself on the girder. It was just
great TV. Horrible science.
My goodness. It's fun. It's fun to go back and watch some of those things, and it's like, oh my goodness, this stuff was so silly.
So my wife
stars.
pointed out that you have to be a little bit careful if you happen to Google Jamie Summers these days, because somebody in the adult industry took that name. So just
man, how dare they?
Be aware that will trigger the not safe for work filters. Lindsay Wagner is still safe.
Do we want to ask what the adult star has for bionic powers?
That's a whole nother story.
That's a whole other group. Yeah.
Let's keep this meeting kids safe, okay?
There you go.
Well, what happened to the great guest stars they had? Wasn't Andre the Giant and Richard Keel on those shows?
Yeah.
I forget which one played Bigfoot.
Yeah, they had a couple. I think they had a couple of different guys. Andre the Giant was one of them, and then I don't know if
they had a whole arc with Bigfoot, didn't they?
Yes, they did. Space aliens and all that. Yeah,
I'd forgotten about
Stephanie Powers. Remember that? She was an alien. Yeah.
Really?
She was an alien? Now I
She
got to
was
go
an
back and watch
alien.
the show.
Yeah, yeah. And that was in Bigfoot was kind of like her pet.
Oh, goodness. I'd get through about a quarter of one episode and just go, nope, can't do it. too schlocky. Too bad.
Oh yeah.
Yeah, but those were the times.
Those were the days.
Yeah. Those are the
That's
days.
that's what TV was like in those days.
And you had 50 plus minute TV episodes because they didn't have 20 minutes of commercials per hour.
Yeah, exactly.
Yeah.
What's the thing about, we talk about the good old days? We weren't good, we weren't old, and we were thinking about the nights.
Nice.
Oh boy.
I actually went back and watched a few years ago. I watched an old Incredible Hulk episode with Bruce Banner, the one played by I can't think of
Bill
his name.
Bixby.
Bill Bixby. And the writing in that actually wasn't that bad. I thought it was going to be horrible, but it was actually pretty decent. I think that was a very thoughtful show, despite the completely ridiculous premise.
Well, I mean, it's all about a guy with guilt and anger issues, right? Who happens to be a scientist.
That's a great combination, right?
Right.
I don't know if anybody's been watching this, but there's a anime show. I think it's on Netflix. Is it Prometheus? I think is the name of it. But it's about a guy who ends up being kind of uploaded into a computer, and it's about it. The show is used to discuss. I'm sorry. It's called Pantheon. Is the name of it.
Heard of that?
No, I think you're thinking of the Electric State.
No, Pantheon I've heard of. They did one season of it, and then they canceled it or something like that. But there was another season in the can, and they're trying to get it out to people, or depending upon how you do it, you can see it. But it's hard to see it in the U.S., but you can see it in like Australia or something like that.
Well, that was the case, but they have now released the second season on Netflix. I just looked it up. So yeah, actually, quite good. I was surprised by how enjoyable that was. And then the other one is Sojourners. Oh, good grief! I'm not going to be able to remember it. Sojourners something or other, which was absolutely fantastic animated series about a weird planet with all kinds of strange life forms. So if you're into that kind of stuff, you'll get a kick out of it.
Well, I'm gonna call it a wrap. What do you think?
Yeah,
Plan.
that's stuff to do too.
All right. Well, glad you guys hung out, and we had some interesting chats, and we'll get this presenter back sometime down the road, and so I'll see you guys again next month.
Is this 2 in a row where the presenters didn't make it?
Yeah, it's well, I mean, stuff happens,
Yeah, for sure, but
it's
You're going to have to start having backup presenters or something like that.
Yeah, sometimes, and I mean, in this case, we were having an interesting chat about this other stuff, and it was like, well, let's just keep doing it,
Yeah, there you go.
That's always an option too, as long as there's something to talk about.
What's I'm trying to remember who it is. Is it Jimmy Kimmel and the guy from Good Will Hunting? They have an ongoing gag where he keeps pretending that they run out of time for him to be on the show, like he's the backup performer, and then they run out of time, and it's turned into quite the little feud. It's fun. So yeah, I don't know who gets to be the backup presenter. That's a pretty backhanded compliment, I guess.
Right.
Well, Steve has a list of things we could talk about if we get completely stumped.
Right, and those forum or those facilitated discussion things. Yeah, I got a whole ton of that kind of stuff. So it's like you guys always seem to come up with something, though. I mean, it's.
Well, I mean, certain things are always in the news, like the GPT stuff. It's very fast moving, so there's always something to talk about.
Always, yeah. So, all right. Well, you folks all have a great month and rest of the day, and I got a little bit of sunshine today here. I don't know what it's like in the down south or over in the on the West Coast, but
Raining.
Not raining here.
Okay.
All right.
At least no tornadoes.